This kind of question, the question asks to determine the following metric is the inverse metric of this metric or not. Let's say we call it as metric A. So we want to prove the given metric is A inverse of A. So we assume that this metric is the inverse for A. So we consider that. So we have to use this relationship, which A times A inverse equal to identity. So we multiply these two metric A and A inverse. We do this method row times column, the sum of it will get 9, and then we do the same thing, row times second column, sum of it will get 6, and we do for the row 2, we times column 1 and we'll get 14, and we do for the last one, we will get 11. So this one is the product of A inverse. Is it equal to identity? Not, right? So we can say that 4, 1, negative 7, 2 is not an inverse for this one. Okay, let's see example B, given that this is a inverse. So we use the relationship A times A inverse equal to identity. So we substitute our metric A given by the question and A inverse, and do the same method for multiply for two matrices, and then by multiplying it you will get this one. This one is an identity metric. So we prove that 2, negative 1, negative 7, 4 is an inverse for this one. Okay, for example number 2, for this kind of question, we need to identify the keywords. Okay, given that this times A equal to identity. Macam familiar, right? This is a relationship. Okay, that the keyword number 1. Since we know this is a keyword number 1, it shows that when we multiply two matrices, got identity. So that means A is the inverse for this one. Mean this one is the inverse of A lah. Okay, so we know that. So we do the inverse of A. Given A is this one. 1, 2, 3, 8. A inverse. Kan? We want to find A. Terbalik kan? So macam inverse kan balik A inverse dapat A. So we do the using the formula AD minus VC. A and D change place, negative B and C change the sign, and we will get this one.